Hello friends, and welcome to a lecture on Python. Today we will learn how to solve a problem of reaction kinetics using Python. Let's have a look at the problem. A reaction A to B is of the order 1 with respect to A. The kinetic expression is given by dCA by dt is equal to minus Ka into C. Find the concentration of A at 5 minutes. The initial concentration of A in the reaction mixture is Ca is equal to 0.2 mole per liter. The rate of reaction is, the rate constant for the reaction, is K is equal to 0.3 minute inverse. Now, dCA by dt, well, the time here in the expression dCA by dt is in minutes. It's evident with the unit of K. And the unit of concentration is moles per liter. This is a first order reaction, and we need to find out that what is the concentration of A at 5 minutes. The concentration of A falls as the reaction proceeds. Now, it's a problem in differential equation, so we will use ODE int in Python from scipy.integrate to numerically find what is the solution to this problem. So to do this, first we have to import the libraries. So we'll import numpy as np and then import from we import ODEINT. This is the library for solving differential equations. And then we import matplotlib.pyplot as plt for plotting the results. So, I made a slight mistake here. Instead of going to markdown, I have to take it as code. Yeah. And execute this. So we have imported all the libraries. Now first we have to write a model. So we write def as one, and the first variable in this expression or in this function is going to be the dependent variable. Now the dependent variable is Ca, that is the concentration of A, and the independent variable is time. It would be advisable, as it is shown in the card above, that you have a look at this video which the card indicates to understand how do we solve differential equations using Python. Now, dCA dt is equal to minus K is 0.3 into Ca, and we return dCA dt. So here our model is ready. Now we have to make an array of the independent variable, that is time. So this command, that is t is equal to np.linspace is equal to 0, 6, 30. It creates 30 equispaced points between 0 and 6 minutes. Now we get ahead with solving for Ca. So we write CA is equal to ODE INT is equal to REACN MODEL 1. The first variable for this library is, that is ODE int, is going to be reaction model. You have to enter the first variable is the model. The second variable, of course, is the initial value of CA, which is nothing but 0.2. And the third variable, of course, is time. So now let's plot this. So we write PLT dot X label. Now the X label is time in minutes. The Y label is CA. And let's draw the plot now. So we write PLT plot T comma CA, and then we put a legend for the plot. So PLT dot legend, and in the legend we want the legend for the curve, which is going to be nothing but CA. It's a expression of CA versus T. So we write it as CA, and of course we need the grids to read it properly. So what we are going to do now is enter, and there we see we get the plot. Now it would be a great idea to have the grid in the plot. That makes it a bit clearer to read. So we can write here PLT grid and run it once again, and there we have the grid. Now what if we want to find out what is going to be the value of CA at 5 minutes? Now to read it from the graph, it is going to be a very difficult proposition. So we can go on this way. We can find out what would be the index of 5 minutes. You see, T was an array, the time was an array, and let's print out time, print time. Now we would like to know what is the time which is closest to 5 minutes. Now that would be the concentration at 5 minutes roughly. So for that, what we do is we put numpy dot arr min, and then we write np dot abs absolute t minus 5. That's argmin. So we get 24 is the index of the number in this which is closest to 5 minutes. Now we take CA and we just put this index number, and there we are. So of course it should be in a square bracket. So there we are. Right. Now it could be combined also. These commands could be combined also. We can write CA and in square brackets, and we can pick up this and put it here. Well, you'll get the same result. So 0.045 is the concentration at the 5th minute. Right? So that's what you are going to get the concentration as. Now, if you want better results, then you'll have to take more points. And of course, you will get a decimal value in the array which would be closer to 5 minutes. So that was all about how you use Python to solve a problem on first order kinetics. Hope you have understood and you have enjoyed this lecture. More such lectures will be coming, and you will really enjoy using Python for solving problems in chemical engineering. My aim would be first to take up problems in chemical reaction engineering, and later on take it in other areas. Okay guys, that's all for now. If you have enjoyed it, do like and subscribe my channel. Goodbye.